From a distance, an antimatter Earth would be indistinguishable from our own. Imagine gazing at it through a telescope. It would be a vibrant sphere, a swirling blue marble. Continents, painted in hues of green and brown, would be etched across its surface. White wisps of clouds would drift lazily across its atmosphere. Oceans, vast and blue, would reflect the light of a distant sun. Even up close, the differences would be subtle. The antimatter Earth would still experience the same weather patterns. It would have rain, wind, and even the occasional thunderstorm. Its landscapes, shaped by the forces of erosion and tectonics, would appear remarkably familiar. From towering mountain ranges to sprawling plains, the antimatter Earth would be a mirror image of our own. A world both alien and familiar, it would beckon us closer. It would ignite our curiosity. But beware, for the beauty of this mirrored Earth hides a dangerous secret. The very atoms of this twin Earth would be different. They would be composed of antimatter. Every particle of matter has a corresponding antiparticle. It is a mirror image. An antiproton, instead of being positively charged, carries a negative charge. Positrons, the antimatter counterparts of electrons, are positively charged. Imagine a hydrogen atom, the simplest atom in our universe. It has one proton and one electron. Now picture its antimatter twin. This atom would be made of an antiproton and a positron. Despite these reversed charges, the physics and chemistry of an antimatter Earth would largely remain the same. The electromagnetic force, the glue that holds atoms together, works the same way with antimatter. Chemical reactions would proceed as they do in our world. Water, composed of two antihydrogen atoms and one antioxygen atom, would still be essential for life. The true danger of an antimatter Earth lies in its interaction with matter. When matter and antimatter meet, the result is explosive. It is an annihilation. Both particles cease to exist. Their mass is converted into pure energy. Imagine a single gram of matter coming into contact with a gram of antimatter. The energy released would be equivalent to a small atomic bomb. Now magnify that to the scale of an entire planet. The collision of Earth and an antimatter Earth would be an unimaginable cataclysm. It would be an event of unimaginable violence. The two planets would be instantly vaporized. The energy released would be greater than that of billions of stars combined. It would be a cosmic event visible across the universe. The existence of an antimatter Earth is highly improbable. It is a fascinating thought experiment. It highlights a profound mystery about our universe. Why is there so much more matter than antimatter? The Big Bang, the event that birthed our universe, should have created equal amounts of matter and antimatter. Yet, our universe is dominated by matter. Where did all the antimatter go? This is one of the biggest unanswered questions in cosmology. Perhaps, somewhere out there, hidden in the vastness of space, there are pockets of antimatter. Perhaps there are antimatter stars, galaxies, even entire antimatter universes. It is a tantalizing thought. Until we find evidence, the mystery of the missing antimatter will continue to captivate our imaginations.